we're going to find the probability of a random variable x. We can find probabilities given a z-score by using the standard normal distribution. Now we'll extend this concept to find the probability given any random variable that follows a normal distribution. So these random variables may be heights, weights, times, etc. of individuals. The key to finding the probabilities associated with the random variable x is to convert x to z to find probability. So the idea is going to be they're going to tell you that heights of something, weights of something, times of something follow a normal distribution. So what we're going to be able to do is take that random variable x that represents the heights, weights, times, convert it into a z-score, and then find probability. We don't have a table that has the probabilities if you're given like the average height of males is 70 inches with a standard deviation of 2 inches. We don't have a table of values that will find probabilities given that specific mean and standard deviation. Because if the average height of men is 71 inches rather than 70, or if the standard deviation is different than 2, then it's going to be a different curve with different probabilities. Even if it's a normal curve, it's going to change the probabilities. So what is always the same probabilities are on the standard normal curve when you use z-scores on the standard normal curve. Okay, so again, the idea is we're going to convert the random variable x that follows a normal distribution into a z-score that follows the standard normal distribution, and then convert that to probability. The formula that always relates x to z is your z-score formula, x minus mu over sigma. So as the example, suppose the wait time on Friday nights at a busy restaurant is normally distributed with a mean of 40 and standard deviation of 6. Random variable x represents an individual's wait time. So if we want to find the probability that x is less than 46, that's just asking you, what is the probability that if you randomly choose the wait time, that they wait less than 46 minutes? Okay, so what we do is we're going to convert x into z by using our z equals x minus mu over sigma. X is 46. The mean is 40 because they told us. And then divide by the standard deviation. And that gives you a z-score of 1. So the probability that x is less than 46 will be equal to the probability that z is less than 1. So what we do is we create a normal curve with our z-axis. And now we know that if this was an x-axis, we would have the mean of 40 right in the center, and 46 will be over here on the right of 40. Well, now what we know is that's a z-score of 1. So the same location where an x value of 46 is, we know that's a z-score of 1. And all that's saying is that 46 is 1 standard deviation above the mean of 40. Okay, so we want to find the probability that z is less than 1. Well, now it's a problem that we've already done. If we want to be less than 1, we're shading to the left. So that's when you go to your table and you look up a z-score of 1.0. And that gives you 8413. Okay, so that probability, that area to the left, is 0.8413. So equals 0.8413. Okay, so that's your answer. Okay, the next one, find the probability that a wait time is less than 32 minutes. So that's when you, again, use your z-score formula, and you get a z-score of negative 1.33. So when you make your normal curve on an x-axis that had a mean of 40 right in the center, we know that 32 is going to be down here a bit to the left. And we know that z-score is now negative 1.33. Okay, so again, the only thing that's really different here than just using the z-score table right away is that we're given a random variable x. We have to do this conversion first. But once you know that z is less than negative 1.33, so we're shading to the left of that because less than. Now it's just looking up in the table what negative 1.33, or the area to the left of negative 1.33. So negative 1.33 gives you 0.0918. Okay, so this area over here is 0.0918. Okay, so moving on to the next one. Now we want to find the probability that x is greater than 30. So I'm going to suggest that you pause the video for a minute. The difference in this one is now we're looking at a greater than rather than the less than's up here. So that'll change your answer a little bit. But I suggest you pause the video and try it. And I'm just going to show you the answer and how you do it. Okay, so you find the z-score by x minus mu over sigma, you get negative 1.67. Remember, you always round to the nearest hundredth. And then you could convert the x into z. And then this is a greater than, so that means you're shaded to the right-hand side here. 30 is going to be on the left-hand side of 40, so negative 1.67, that z-score is 1.67 standard deviations below 0. So when you look up the area in the table, negative 1.67, okay, so negative 1.67 way over here, gives you 0.0475 for the area. But remember, that's the area to the left. We're greater than on this one, so we have to subtract that from 1 to find the area on the right. So you end up with 0.9525. Okay, and then on the last one, this one is just asking the probability that x is between 42 and 52 minutes. So if you randomly choose someone, what's the probability they wait between 52 and 42 minutes? Okay, and this one involves finding the z-score for each of them. And these are always a little bit tougher because students sometimes get confused on what you do when you find those two z-scores. Well, the idea here is now when you make your diagram, okay, so here's your diagram down here. Remember that when you look up 2.00, that's the area all to the left of 2. So the area from here all the way to the left. And when you look that up, that's what 0.9772 is. That's all the area from 2.00 to its left. 0.33 to its left is 0.6293. So the area from here to the left is 0.6293. So to find the area in between them, you take the larger area minus the smaller area. Okay, and that'll give you 0.3479. Now the good news on our calculator, those are actually the easier ones on the calculator. Okay, so if you find the z-scores first, and this is the way that I want you to do it if you use your calculator. Okay, using the normal CDF. Once you find the z-scores of 0.33 and 2.0, remember you go to second bars and then down to normal CDF, and you put in the left-hand z-score or the lower z-score, and then comma the upper z-score, and that'll give you area. Now sometimes that fourth decimal place might be 0.0001 off, or maybe 0.0002 off. but that's just because of rounding your z-scores to the nearest hundredth. Okay, so that one's actually not too bad. Now, just to show you on that part C to do that, again, you do normal CDF. Oops. Now the lower z-score is negative 1.67. And the upper z-score, oops, I'm in y equals for some reason, sorry. Okay, so normal CDF. Lower z-score, negative 1.67. And the upper z-score, well, we're going all the way out to the right here. So that's when you put in a number like 10,000, which just means you're going 10,000 standard deviations above the mean, which is way out there to the right. And that gives you 0.9525. Okay, on the second page, okay, here we're looking for the probability that a wait time is between 20 and 30 minutes. So that's the probability that X is between 20 and 30 minutes. So this is just like that last one. You find the z-score of each one. And if you want to take a minute and pause the video, go ahead, but I'm just going to keep on moving along to keep it shorter. Okay, there's the shading of it. We know that negative 1.67 and between that z-score and negative 3.33, you take this larger z-score minus the smaller. The area, let me rephrase that. You take the area to the left of that right-hand z-score minus the area to the left of the left-hand z-score. So 0.0475 is what you get when you look up negative 1.67. And 0.0004 is what you get when you look up negative 3.33. So subtract those and that'll give you the area between them. And on the x-axis, that's the probability that you're between 20 and 30 minutes. And then percent of people that wait more than an hour. Okay, again, pause the video if you need to. But that's just asking you the probability that x is greater than 60 minutes. So you find the z-score, which turns out to be 3.33. Notice it's going to be symmetric with this one up here. And then when you shade the diagram, you're on that right-hand side of 3.33. Okay, so x is greater than 60. That's how it shows up on the x-axis. But we're using the z table. So to the right of 3.33, you have to do 1 minus the area to its left. So all this area out here to the left is 0.9996. Okay, and that's just looking up in the table. Okay, so that's how you find the probability of a random variable x.